This is lesson 5.2, College Algebra, Systems of Equations in 3 Variables, starting on page 451. So what we're doing here is we're looking at systems of equations that have 3 variables, which means there needs to be 3 equations. Just like in the last lesson we did a system of equations with 2 variables, so therefore there were 2 equations. And we used elimination and substitution in order to solve that. Well, what we're going to do in this lesson is the same thing. Use substitution and or elimination to solve systems of equations in 3 variables. The only difference is there's an additional step or two, but really you're just looking at 2 equations at a time. So although there might be 3 equations, we're only looking at 2 at a time and going from there. So we're going to use what is called Gaussian elimination, and that is in the middle of page 451. Now I do it very similar to the book, but then again a little bit different. So let's go ahead and do the first example there and get started. So there are our 3 equations there, and we're trying to find the value of x, the value of y, and the value of c. So again, and what we're doing when we find x, y, z is we're looking for a point on the coordinate system that all 3 of these equations intersect. And if you look on page number 454 and you look at the first example there, it says one solution, planes intersect in exactly 1 point. So what we're looking at here is each one of these equations is 3-dimensional. There's an x, there's a y, and there's a z. So actually on the graph we have a y coordinate, an x coordinate, and then we have a z coordinate. That actually the z coordinate comes right out toward you. So it's, it goes through this point and it comes right straight toward you, and since I can't draw it that way, most books will show the z axis like that. And so there is a point that you go over x, up y, and toward you z for a positive z, or away from you on the other side of the xy axis for the negative z. So when we get an answer such as this particular problem, our answer is 3, -1, 2, that's our x, y, z coordinates. We go over 3, down 1, and then toward you, which obviously you can't show that, toward you 2 units. So that's what we're doing with x, y, z, is we're getting a point, such as in that first example on page 454, that all 3 planes have in common, that intersection point where there's only 1 point that works. And then there's 4 other options or possibilities that you can get with this, but we're looking at just that first one right now. So all of that, and let's go ahead and solve this. So in order to solve this, the instructions on the bottom of page 451 in blue says interchange any 2 equations. Well, I kind of ignore that. What I'm looking at doing is getting any 2 equations I want and get rid of one of the variables. Because remember, if we have 3 equations and 3 variables, we can solve for the 3 variables. If we have 2 equations, if I just pick this one and this one, I can't solve it because I have 3 variables. But if I can eliminate one of the variables and just have 2 variables with 2 equations, I can go ahead and solve that. So that's what I'm going to do. I'm going to get rid of 2 of the variables and have 2 equations with 2 variables, and life will be good then for me. So let's go ahead and do that right now. And because of this equation, they've made it rather simple to solve for x and then y and z. But we're going to go kind of a roundabout way of doing it, because normally solving these are not so simple. Now the simple way would be to take these 2 equations, add them up, my y's would disappear, my z's would disappear, and I would get 5x equals 15 or x equals 3. And I just found one of my variables. But we're not going to do it that way simply because most of the time it doesn't work out that easy. So let's pretend that it's not going to work out that easy. And let's look at 1 and 2, but let's get rid of the x. Okay, so we're going to get rid of the x so that all we have are y's and z's. So then we have two equations with two variables, y and z. So let's get rid of the x. So in order to get rid of that x, we multiply the whole thing by -4. Okay, so we're just looking at this right here. We're going to ignore that third equation right now. And we get -4x plus 8y minus 12z equals -44. In my second equation, I don't have to do anything because I already have a 4. 3z equals 4. Okay, then I'm going to add those. So those go away, and I end up with 10y minus 15z equals -40. So now I've got my one equation. Now let me circle it here. I've got one equation with a y and a z, and that equals -40. So now what I'm going to do is I'm going to pick another two equations and get rid of the x there so that I have just a y and z, and I can compare it with this one. So I'm going to draw a line down here, keep everything kind of separate. And let's see, I'm going to take the first equation and do the system of equations with the third equation. So I've got that one, and let's do the 3x plus 3y minus z equals 4. Alright, so what I'm going to do is I'm going to eliminate the x. So in order to eliminate the x, I'm going to have to multiply the top by a -3 in order to do that. Alright, so when I do that, I get for my top equation -3x plus 6y minus 9z equals -33. In the bottom I get 3x, I didn't do anything to the bottom, 3y minus z equals 4. Add those together, my x's disappear, I get a 9y minus 10z equals -29. Okay, so now I have two equations. I have this equation here, right there, and I have this equation there. Well, I'm going to put them together and ignore everything else at this point. So I'm going to take this stuff and move it up out of the way here. So I've got my 10y minus 15z equals -40, where I got rid of the x. And then I have 9y minus 10z equals -29. Okay, so I took this one here and this one here. Since I got rid of the x's, now I have two variables and two equations. Now I'm going to do the stuff we did in lesson 5.1. So I am going to multiply the top by a 2, because I want that to be a 30, and I'm going to multiply the second one by -3, because I want that one to be a positive 30. So I'm going to have a -30 here and a positive 30 there so that I can eliminate my z's. Okay, so let's go ahead and rewrite these as 20y, this is the top equation, minus 30z equals -80. And the bottom one is going to be -27y plus 30z z equals positive 87. Okay, so now when I add these will go away. I've got negative 7y equals 7, so y equals negative 1. Alright, so there's the first solution to my journey. I found out that y equals negative 1. Now I have to do what is called back substitute and try to find out if I can find my x and my z based on y equals negative 1. So let's go back all the way up to some of these other equations here. In fact, let's go to any equation that just has two variables. Well, I can really look at either this one or this one. Doesn't matter because I have a y and a z. So, or I mean, I guess this one and this one doesn't really matter. But let's take this one here that has a y and a z, and I'm going to put a negative 1 in for y because I just found out y equals negative 1. So negative 9 minus 10z equals negative 29. Negative 10z equals negative 20. So z equals the number 2. So that was quick and easy to find my z value. Okay, so now I've got my z is 2 and my y is negative 1. I need to hop up here and find a problem that has an x in it. And as I scroll around here, I have one right here. So I'm just going to put a negative 1 in for my y, a 2 in for my z, and then that will give me an opportunity then to find what my x value is, and I find out my x value is 3. So now I've got my x, y, and a z, and I write it this way. Let's get some stuff out of the way. X is 3, y is negative 1, and z is, 2. That is a 2 with parentheses. So x, y, z there. So that's how you do that with 3 variables. Okay, so because there aren't a whole lot of examples from the book, I'm taking number 4 from the exercise set, and we'll go ahead and do this. So again, it doesn't matter which of the 2 equations you pick to eliminate one of the variables. So I'm going to just pick these 2 right here, first 2. And in order for us to eliminate, I'm going to eliminate the x. So if I eliminate the x, I'm going to have to multiply the top by negative 2. And the bottom I can just leave alone. Okay, so when I do the top, I end up getting negative 2x minus 2y minus 2z equals negative 12. And I'm going to leave the bottom alone, like I say. And I'm just going to rewrite that. And then I've got my 2 equations that I can add my terms to. So when I add these 2 together, they zero out. When I add the y's, I get negative 3y. When I add the 2z and the negative z, I get negative 3z. And when I add this, I get negative 15. So right there is one of my equations down to 2 variables. And the next one I'm going to do, let's go ahead and put the first and third together. So that's x plus y plus z equals 6. X minus 2y plus 3z equals 6. So I'm getting rid of the x's again. So fortunately for this one, they have the same coefficient. So all I have to do is subtract one from the other. So let's put a minus sign. X minus x is 0, so those go away. Y minus negative 2y is 3y. Z minus 3z is minus 2z. And 6 minus 6 is 0. So now I have another. Now I can put these two together. And I've got negative 3y minus 3z equals negative 15. And 3y minus 2z equals 0. So I took that one and that one. Now I'm going to add them. These will cancel. Negative 3z plus negative 2z is negative 5z equals negative 15, giving me a z value of 3. Okay, so that is the hard part. Now all I have to do is go back and back substitute. So I'm going to look at my z equals 3, and I'm going to try to find an equation somewhere in this mess where I only have one other variable that I can solve, because I can plug a z in for one of them and I'm left with one variable. So I'm going to go to this one. Could be this one, could be this one, doesn't matter, but I have more space down below here. So I'm going to put a 3y minus 2 times 3 equals 0. So 3y minus 6 equals 0. 3y equals 6. Y then equals 2. Okay, so now I have a z and a y. Now I can take both of those and find any of these equations up here that have 3 variables. So, such as this one. Plug my 2 in here, my 3 in here. 2 plus 3 is 5. 5 plus something is 6, and that something is 1. So I know that my x then equals 1. So, again, the way you would write this is like we had mentioned before: 1, 2, 3, x, y, z. Okay, so this is number 10 in exercise set 5.2, page 457. Alright, so number 10, what we're going to do here is, well, let's look at the first equation and the third equation. So let's look at this one and this one, since they both have x's there. So x plus 3y plus 4z equals 1. X plus 8y plus 11z equals 2. And to get rid of my x's, I'm going to subtract. So those go away. 3 minus 8 is negative 5y. 4 minus 11 is negative 7z. And 1 minus 2 is negative 1. So there's one equation that I got rid of the x's. Now let's do the first one and the second one here. Alright, so again, the first one and the second one. So we have x plus 3y plus 4z equals 1, and 3x plus 4y plus 5z equals 3. So we're going to multiply this top one by negative 3. So we get negative 3x minus 9y plus, actually it's minus 12z equals negative 3. And we'll just restate that second equation there to get it there below. Alright, now we can add. Those go away. Negative 9y plus 4y is negative 5y. Negative 12z plus 5z is negative 7z. Negative 3 plus 3 is 0. Okay, so look what we end up with. Negative 5y plus 7z equals 0. That's our second equation. So let's bring them both together over here and over here. So we get negative 5y minus 7z equals negative 1. Negative 5y minus 7z equals 0. Now if we add those together, we get 0 plus 0 equals negative 1. So we have 0 equals negative 1. Now one of the things, remember, that we figured out, that is when we bring our two equations together, if we get something that is untrue, then we have no solution. In fact, if you look on page number 454, and they give the 5 different plane intersections or solutions there, you'll notice that we have a couple times where we have no solutions. We have that middle one on the top where it looks like a tent. There's no solution. Because we have a couple solutions, like plane 1 and 2 intersect, and 2 and 3 intersect, and 1 and 3 intersect, but 1, 2, and 3 do not intersect at one point like they do on the one on the left. Or we have another option of all 3 of the lines are parallel to each other, so there's no intersection. So anyway, you have your 3 different options there, or your 2 different options of no solution. And also when you do this, I think we're good to go. You're either going to get an answer or you're going to get a no solution, because you're going to get something like this.